Amit, and this is my second video of my channel. Today I'm going to explain you the daily question 2206, divide array into equal pairs. It's an easy question, and you can see that the data structure that is used over here is array. And let me read out the problem description. The description is you are given an integer array nums consisting of 2 into n integers. So the nums length is equal to 2 into n. Let's say n is any given integer that is positive. How do I know it is positive? Because in the constraints I have seen that n belongs to 1 to 500, both included. Now you need to divide nums into n pairs. So basically our task is to see that if we divide nums into n pairs, and we know that it can be divided into n pairs because the number of elements inside n is always 2 into n, and we need to satisfy these two conditions. Each element belongs to exactly one pair, the elements present in a pair are equal, and if and only if both of these conditions are satisfied, we need to return true. And if can't be satisfied, if any other condition is failed, in that case we would have to return false. So it's a boolean solution problem. So basically we have to either return true or false in this case, and both of these conditions should be met. So in this first condition is that each element belongs to exactly one pair. What does that mean? For that, let me go to a next tab. I have Excel Draw in it. I have an example over here, and this example states this is nums. Let's say this is nums, and inside nums we have these elements 3 2 3 2 2 2, and I represents the index of these elements, 0th index, first index, and so on. So it says that, let's say I have chosen this is P, this is solution 1, let's say I call it P1, and this is solution 2, I call it P2. In solution 1 I have taken 3 from 0th index, 2 from first index, and 3 from second index, and 2 from third index. That means that in this particular statement it says that each element belongs to exactly one pair. It means that the 0th index element should always be present in a single pair. Let's say this is called P01, P02, and P03. 0th index element can only be present in P01 or P02 or P03. It should not be an AND condition. It can't be present in multiple pairs over here. So that's the reasoning behind this particular statement. The elements present in a pair are equal. So if you see in this particular solution P1, we have a pair called as 3 2. The elements in this pair are not equal to each other, so it does not meet the second condition. And since it does not meet the second condition, so this particular solution for this problem statement, for this example, if we have the solution, is false. So now let's say how can we say that if it's a true or not? We can't formulate different combination. So what we can do is that we can look at the keywords that is used over here. That is a pair, and it's given that it is 2 into n integers, and we need to make sure that elements present in a pair are equal. So in this case we do not need to make the pair, but what you can do is that we can calculate the frequency of an element. Let's say that in this case 3 is present 2 times in nums, and 2 is present 4 times. So if we, since to make a pair we can divide it by 2, let's say if I divide it by 2, the remainder will be 0. That means we can actually form a pair using 3, and if we do so using 2 over here, the remainder will again be 2, and the basically the quotient will be 2 over here, because we can divide 2 into two different pairs over here, 2 2 and 2 2, and in this case we have two number of 3, so we can divide into a single pair. So similarly, if you let's say have 4 4 5 5 6 6 and 7 7, so we do not need to make a pair out of itself. We can first of all calculate the frequency of these elements. If the frequency is divided by 2, that means that we can form a pair. If it is divided by 2, that is the modulo of 2 is equal to 0. That means there is no remainder in this case. Let's say that we had a 3 over here. In this case, the number of elements of 3 will be 3 over here. The frequency of 3 in this nums will be 3. 3 divided by 2, the remainder will always be 1. So in this case, there will be always 1 3 that does not have a corresponding 3 in it. It doesn't find a pair of 3 in it because it is 3. It is not divisible by 2. So in this case, we can directly calculate the frequency. Let me code it out in JavaScript. So let me have an object. It's called element frequency that will store the elements frequency. Now let me loop through this array. Array is equal to 0, and in this case I need to go through, I can cache this length over here. So what I'll do is that I'll just do nums length and this is not needed, but it'll in interview settings it will be helpful if you basically try to find a modular code that is corresponding to enterprise level code, so it helps us additionally. Let's say I have nums length, I put it over here and I increase this index I plus plus, and if I need to check if element frequency of the current element, in this case I can kind of const current character is equal to nums of I, and I found the current character. Now this current character, if it is not present, is if it is equal to undefined, which is, let's say initially it is an empty object, so when I looping through this nums, I find the 0th index element, that is 3, is something that is not present inside element. In that case, what I can do is that I just put it as 1, or else we just increase the frequency over here. That is it. So basically this node, this calculates the frequency of an element in nums. Nums is the input array. Now what we can do is that we need to loop through the object. I can do through using key in, or I can say element, because the key is element itself, in element frequency, and I'll just do return true over here. Why would I say return true? Because while you are looping through the element frequency over here, if you at any point in time find that this is not divisible by 2, you can return false. If everything is divisible, we can directly say it is return true. So we can find const frequency, and frequency will be element frequency of the element. We will find the frequency. Now we will check if frequency modulo 2 is not equal to 0, then we return false, or else we just move on. So this is should be clear. Check if the frequency of an element is not divisible by 2. Since we need to make a pair, we need to check it. So basically this loops through all of the element inside this object element frequency, and then we take the value of that particular key of that object, and we just check if the frequency modulo 2, that is the remainder, is not equal to 0. In that case, return false, or else return true. I click on run, accepted. Once I click on submit, other default test cases are getting accepted right now, and I have, you can see that it is 3 ms the runtime, and if it's 82.95%, and in this case it is, if you look at the complexity over here, so the time complexity, since this is num sub length, and the time complexity will be 2 into n in this first pass, so it will be O of 2 into n, that is equal to n itself tends to n, and in this case this will always be less than n. So the total time complexity will be big O of 2 into n plus something of n, so it will be total of big O of n. In the first pass it is big O of 2 into n, the second pass the number of elements. Let's say in this case, worst case scenario, it will be each and every element are unique. In that case it will be again n. In that case it will be O of n. O of 2n plus O of n is equal to O of n. So yeah, thank you so much for watching this video. Hope you have a good day.